Okay guys, I wanted to make a video to help you guys on a few of the problems on the study guide. If you need help solving system of equations, I would go back and look at some of the other videos that I already made on those different types, like the elimination, the solving by graphing, and the solving by substitution. Alright, so we're going to look at solving systems here, and we're looking at number 9, and then we're going to look at number 10 before we go on. Alright, so let's start with number 9. We're supposed to look at these and identify which method is going to be best. You could solve this with elimination by multiplying by -7, but I think the easiest thing is going to be to solve it by substitution. So the first thing we're going to do is we want to get rid of the -3x. Let's write this outside here. So -3x plus y equals 17. So we want to get rid of the 3x. So what we're going to do is we're going to add a positive 3x to get that on the other side. Okay, so that'll leave us with y on this side, and then a 3x plus a 17. Okay, and so once we have that, we have it solved for y here. So now we can just plug y in over here to solve for x. And so let's do that. So we'd have 8x plus 7. I like to put my parentheses there to show where I'm going to put y. 3x plus 17. And parentheses mean multiplication. So what we're going to do next is distribute this in. 7 times 3 is going to be 21. Have to bring our variables. So it's 21x. And then a 7 times 17 is plus 119. So let's bring down everything else we have here. That's going to be an 8x. And then equal to 3. Okay, so now we're going to combine like terms. So we have a 21x and an 8x. That is equal to 29x plus 119. Bring everything else down. Objective is to get x by itself, so we want to subtract 119 from both sides. Bring down what we have left, which is a 29x, and a 3 minus 119 would be -116. And then our last step is going to be to get rid of that 29 off of that x. That's multiplication, so we're going to divide to get that off. Divided by 29. That leaves us with x is equal to, what is that, -4. Okay, so we have x. So we know we have our first number, we have -4. Okay, so now we're just searching for y. So we can get y by plugging in x, which is -4, into one of the equations up here. So let's do that. So you have, let's kind of partition off an area here. So you have -3 multiplied by -4 plus y equals 17. So we do the math. -3 times -4, negative times a negative is a positive, so that's 12 plus y equals 17. We want to get rid of that 12, so leave y by itself. So that's 12 minus 12 on this side. And that's going to leave us to y equals 5. So we know that we have 4, -4, 5. It's going to be our solution. All right, let's look over at number 10. All right, so we're looking at this, and we want to figure out what's going to be the best way to solve it. Looking at this, looks like elimination is going to be the best thing to do, because we're no longer just one step away from making it a solve by substitution problem. So the first thing we want to do is figure out how can we get an opposite on the top and the bottom here. This one appears to be the easiest one to do that, so we know if we multiply that by a positive 3, it would equal a negative 9, and then these would cancel. So let's get to work. We're going to multiply this entire top side by 3. So we carry that in. That'll be 9x. Multiply that in, it'll be negative 9y. Then we multiply that, it'll be equal to negative 9. And so now we're able to eliminate one of our variables, that the 9y, or the y rather. And so we combine like terms. So we have a 9 and a negative 5x. That's going to be 4x left on this side. And then you have a 29 minus 9, of course. It's going to leave you with 20. Last step is to divide by 4. That's opposite of multiplication. And that's going to leave us with x is equal to 5. So we know out here somewhere we're going to have 5 for x. Now we're looking for y. We already have x, so we can just plug in x in one of these guys right up here. So I'm going to plug it into the top one. Let's do that. So we have, let's partition this off. We have 3 multiplied by 5 minus 3y equals negative 3. In doing the math, we know 3 times 5 is 15. Drop down your negative 3y and your negative 3. We want to get rid of the 15 on that side, so we're going to minus 15. Whatever you do on one side, it has to be done on the other. Bring down what we have left on this side, which is a negative 3y. Combine like terms on the right side, and that is negative 18. And then our last step is to get rid of the negative 3. We have to divide by negative 3. Do that on this side as well. And that leaves us with y is equal to a positive 6. And so we have our other answer. And so that is x is 5, y is 6. All right, so these are a little bit harder. So let's look at number 11 here. We have to come up with our own equations. Let's read this to find some information that's going to be beneficial to making these equations. So number 11, Amy's school is selling tickets to Agora Performance. A senior ticket is $6. That's important information. And a child's ticket is $15. Also vital information here. If they made $810 and sold a total of 72 child and senior tickets, that's combined, how many of each ticket did they sell? So we know we have 2 different types of tickets here. We have a senior ticket, and we'll define that by making it X, and then you have a child ticket. Okay. So, how do we begin to write our system? I like to always look at things as the per cost. And so a senior ticket is $6 per. So I know I can write that as $6 per, and that's per senior ticket, since X is for seniors. to get the total cost of that, I know it's going to be combining that with a child ticket, and a child ticket is $15 per. And then our total cost, we already underlined that in here, is $810. And so we'll write that below. It's equal to $810. Okay, now we also defined our variables already, like I already said. So it's X for senior and Y for child tickets. So we have X plus Y. Those are your tickets, not including the cost. And there's a total of 72 tickets sold. And so now we're set up to go ahead and solve this thing and find a solution. I'm going to go ahead and do that by solving this by elimination. So I want to get opposite of this positive 6 down here. So I'm going to do a negative 6 and multiply everything by negative 6. So we know negative 6 times x is negative 6x. And then negative 6 times y is negative 6y. So negative 6x minus 6y. And then negative 6 times 72 is, what is that? 72 times negative 6 is negative 432. And so let's bring down our other system here. We're going to drop that below. And that is 6x plus 15y equals 810. And so now we can start eliminating. There's that elimination. We have a negative 6y and a positive 15. We combine that, and that is 9y. And then you have negative 432 plus 810 is equal to 378. Last thing to do here is to get rid of this 9. We want to divide since that's multiplication. So we have 378 divided by 9. And that's equal to 42. So we know y is equal to 42. Now, all we have to do is plug that in to solve for x. We're going to plug it in the easier one, which is this one right here. And we're going to do that out here to the left. So we have x plus 42 is equal to 72. Going to subtract 42 there. We're just solving now. What's left over on this side is x. And on the right side, 72 minus 42 is 30. So our solution, x is on the left side, 30, number 42 is our solution. And that's number 11. I guess I could say, so we sold 30 senior tickets and 42 child tickets, just to throw it into perspective there. This video is getting long, but I'll show you number 12 also. I know these can be hard. So, all right, the band is selling wrapping paper for a fundraiser. Customers can buy rolls of plain wrapping paper and rolls of shiny wrapping paper. The band sold a total of 55 rolls and made $950. A plain roll costs $14, and a shiny roll costs $20. And so we know we're dealing with plain and shiny roll. Let's go ahead and define that. So we have x equals the plain ones, and y equals the shiny ones. Okay. And so let's look at my per cost. You have $14 per plane combined with, it's a plus, $20 per shiny roll, and we know we had a total cost here of $950, so full right is equal to $950. Okay, so again, we already defined X and Y, so we know we have plain plus shiny is equal to a total of, we underlined it here, 55 rolls. So if you, when you add the plain rolls combined with the shiny rolls, you get a total of 55 rolls. I think I'm going to go ahead and solve this by elimination once again. So I want to multiply this whole thing by negative 14. When I do that, it's going to be the opposite of that positive 14 above it. So that is a negative 14x. Negative 14 times y is negative 14y. And then a negative 14 times 55. I'm going to break the calculator out for that one, folks. 55 times negative 14 is negative 770. Okay, so let's bring down the other equation next to it. So we have 14x plus 20y equals 950. Okay, so you have, and for those of you that aren't following that, I just brought that one down and I put it here, so we have them kind of just lined up next to each other. So now we eliminated what we wanted to eliminate right there, and so we combine the negative 14y and the 20y, and that gives us 6y. And then you have, again, more calculator work here, negative 770 plus 950 gives us 180. I'm going to divide by 6 to get rid of that. Have to do it on that side as well. And so 180 divided by 6 is 30. We know we left y over here, so y is equal to 30. Now we just plug in for y, which we're running out of space here. So where am I going to put this? Let's box it off over here. So you have x plus 30 is equal to 55. And we're just using this equation right here. And so we'll subtract 30 to get rid of that. Subtract 30. We're left with x on this side is equal to, what is 55 minus 30? I don't feel like using my head. That is 25. So our solution is x is equal to 25. I'm sorry, what am I doing? Gotta write it correctly, guys. So you have x is 25 and y is 30. So again, to put that in perspective, there was 25 plain rolls and 30 shiny rolls. Okay, so let's look at our next two. These will be the last two. We're graphing inequalities now. So some reminders here. This is just a greater than sign with no line like this underneath it. So we know that that's going to be represented by a dashed line. Okay. Whereas this one does have the line underneath it. That's less than or equal to. So that'll be represented by a solid line. Okay. We'll look at how to graph these now. That's a -3. That is our y-intercept, and so we know that's on our y down here. It's going to be right there. Do that with red. And then our slope is right here. That's a negative 2x. Same thing as negative 2 over 1. So we go back down to our original point, and we're going to go up 2 over 1. So that's up 1, 2 over 1. This is a negative slope. We know that based on this negative sign here. So the line should be going down like this from left to right. Of course, that'll be a dash though. So again, up 2 over 1. And we keep going up 2 over 1. Go back to our original point, starting point, intercept, and we go down 2 over 1, down 2 over 1. And now we draw our dashes here. I keep hearing my arm sliding on the leather of this chair, and it sounds like a fart. So if you guys are like dying over here thinking I'm farting, you would be incorrect. All right, so that's our line there. So now we're going to figure out which area of the line we're going to shade. And so, like we told you in class, that is a 0, 0 are the points we're going to plug in. So let me erase this right here so I can do it over there. So we're going to say 0 is greater than negative 2, plugging in 0 for x, minus 3. That cancels out, so 0 is greater than a negative 3. That is a yes. So that point is right here. That's the 0, 0. We say yes to that. So if we say yes, that means we shade that portion of the graph. So we're shading all that. Okay. All right. And now we go to our next one, which is this one. It is a positive 2 as our intercept. So we know we're going down to positive 2. We're going with blue on this one. We know our slope is going to be going up from left to right. We also know that slope is 1 over 2. So up 1 over 2. So go back to our original point there. It's up 1, 1 over 2. Up 1 over 2. Going back the other way, it'd be down 1 over 2. Down 1 over 2. Okay. And we know that's going to be a solid line. Now we're going to use our same 0, 0 to plug in for this line. So that's going to be same origin right in here. So we'll put our blue dot there now. Let's plug that in. Y is equal to 0, so we'll put 0 in. And 0 is less than or greater than 1/2 times 0 for x plus 2. That cancels out. Again, all we're doing is plugging in a 0 for y, 0 for x, and doing the math. That's all we're doing there. Okay, that cancels out, so 0 is less than or equal to 2. That is also a yes. So we would shade that area of the line. Remember, we're looking at the blue line. Okay, and so now we want to figure out which area is shaded by both red and blue. And I'm going to shade that in with green. And so both lines are shaded here. And so we know everything in there is a solution. Last one. Number 14. Again, we're looking here. That is less than or equal to, so we know that that's going to be a solid line. And this one is just less than, so we know that's going to be a dashed line. Okay. Intercept is +1 there, so we go down, draw a point at +1, that's our y-intercept. And then just the x there, same thing as that being 1 over 1. So that's up 1 over 1. So positive slope should be going up from left to right. Up 1 over 1, up 1 over 1. Going the opposite way, it's down 1 over 1. Down 1 over 1. And we draw our line. And so we plug in our same thing, 0, 0. That's going to be right there in the middle. And so let's plug that in. So it's 0 is less than or equal to 0 plus 1. 0 plus 1 is 1. So 0 is less than or equal to 1, and that is a yes. So we know we're going to shade the side of the line that our origin is right there at the 0, 0. Okay. Let's graph our next line right here. So we have a -3 for the intercept. That's going to be right down there. Our color is blue, so blue is there. And then we have a negative x, so we know that's a -1 over 1. And so that should be a negative slope. That's going down from left to right. So we'll go up 1 over 1, up 1 over 1. Remember, if it's the same slope, you probably are almost certainly have no solution because it's the same slope. The lines would be parallel. So now we figure out which area of the line we're going to shade, or which side of the line. So we're going to plug in the same 0, 0. So that's 0 is less than -0 minus 3. So that ends up being 0 is less than -3. And so 0 is not less than -3, so that's a no. And that origin, that means we don't shade that area, which is here. And the answer was no, so we don't shade this area. We have to shade opposite of that on this side of the line. So let's do that. Okay, and what area has both shadings? It is this one right here, and we'll fill that in with green. And those are your solutions.